Hello guys, welcome to Self Help Maths Academy. Today we are going to discuss about the discontinuity of a function. So what is the discontinuity of a function? What are the types? Let us understand in this particular video. So a function, say, let me understand the definition. First, let a function f from a to r, okay, or if you consider any function f which is not continuous, maybe if you are considering at a point, then we'll take it as at a point a is said to be discontinuous, at the point a. So basically, if the function is not continuous, we call that function as a discontinuous function. So we have seen in the previous videos where how do we say the given function is continuous. So if that particular function is not continuous, then we call that particular function as discontinuous at a given point a. Okay, so that means, for example, like what may happen when we say that a function is discontinuous. So even like, for example, when you're defining it in the interval, even the function is maybe continuous at every point, but maybe it is discontinuous at a single point. Still that particular function will be discontinuous in that interval. Okay, now maybe, like, what are the reasons it may have in order to become discontinuous. So the first reason, maybe f is not defined at a, because at the point a we want to understand whether the given function is defined or not. Maybe it is not defined at all, so that may be one reason. The second reason may be the limit of f of x as x is tending to a maybe does not exist. Okay, as we know that limit must exist, or that is, it implies what? When I say limit does not exist, means the left hand limit and the right hand limit may not be equal. Like, the left hand limit may not be equal to the right hand limit, that is x tends to a plus. Okay, so this may be there, limit does not exist. Or like, say, maybe the limit exists and function is also defined, but both are not equal. Like, limit of f of x as x tends to a and f of a, okay, both exist, but they are not equal, okay. So now if you see in this case, like, we have three different aspects. Maybe the given function f is not defined at a given point a, that may be the reason. Or the limit may not exist, that may be the reason. When I say limit does not exist, in the sense left hand limit and right hand limit are not equal. The third case is both are exist, the limit exists, even also the given function is defined at a given point, but they are not equal. Okay, they are not equal. So any one of them fails also, we say that the given function is discontinuous. So now let us discuss. We have some types of discontinuities. Okay, types of discontinuity depending on the nature. So we have different types of discontinuity. So let us discuss them one by one. So the function is discontinuous at a given point a. The first one is a removable discontinuity. Removable discontinuity. What do you mean by this? So here what happens? Here, if f of x, a limit of f of x as x is tending to a, it exists, but it is not equal to f of a. Then we say that f is having removable discontinuity. discontinuity. Discontinuity at a point, say A. So this is called a removable discontinuity, because this is actually it has a condition that the limit of f of x as extends to a exists, but it is not equal to the given point f at the point of a. Okay, so when we define a function at f of a, we get f of a that are not equal. Okay, so this type of discontinuity can be refined, it can be defined by removing, this can be, this discontinuity can be removed by defining the new function as, say, g of x. I'm defining this as, say, f of x if x is not equal to a, and this is equal to limit of f of x as x is tending to a, if x equal to a. So we know now what we are defining, whatever the value it takes when I take the x as tending to a, so that will be equal to x equal to a. So if we define this way, then this function becomes continuous. So therefore it is called as removable discontinuity. So in removable discontinuity, now after defining this way, this your g function will become continuous at x, when at x equal to a. So here if, for example, I'll have to give you a note here. The note is if suppose your limit of f of x, say, as x is tending to a, it does not exist. Okay, if it does not, say, exist, then the function cannot be made continuous, no matter how we define f of a. It means what? It means suppose your f of x cannot be, the limit of f of x as extends to a, the limit does not exist. Okay, if the limit does not exist, then however you define your f of a, okay, no matter however you define your f of a, the function will not become continuous. So that is very important. So only what we can do is, only we can remove the given point and redefine it like this as we did it in g of x. But if the limit does not exist, then we cannot define it any way in order to make it continuous. That is very important. Now the second type of discontinuity is discontinuity of first kind. It is called discontinuity of first kind. Also it is called as jump discontinuity. Okay, how do we define this? Here what happens, if in this case, if limit of f of x as x is tending to a minus, that is left hand limit, and the right hand limit of f of x as x is tending to a plus, both exist. They both exist. Left hand limit exists, right hand limit exists, but they are unequal. Then f is said to have a discontinuity of first kind. At a or jump discontinuity at a. So here usually what happens is, in this case we have the left hand limit, we have the right hand limit, both exist. Left hand limit exists, right hand limit exists, but they are not equal. Okay, they are not equal. So that is the important point to be remembered. So here f said to have a discontinuity of the first kind from the left at a if the left hand limit exists but it is not equal to f of a. Okay, left hand limit exists but not equal to f of a. And f is said to have a discontinuity of the first kind from the right from the right, if the right hand limit is not equal to f of a. Okay, so therefore we have gotten a discontinuity of a first kind if the limit, left hand limit and right hand limit exist but they are not equal. Okay, next we have discontinuity of second kind. Discontinuity of second kind. Discontinuity of a second kind. So what happens in this? Here what happens, if neither limit f of x, as x is tending to a minus, from left hand limit, nor the right hand limit of f of x as x is tending to a plus exist. Okay, so what we are saying, neither the left hand limit exists nor the right hand limit exists, then f is said to have discontinuity of second kind. Okay, so again, second kind at a given point, say a. So here we are talking about the discontinuity of a second kind when neither the left hand limit, if you see, neither the left hand limit nor the right hand limit exist. Okay, so then we call it as a discontinuity of a second kind. So here what you are trying to understand is, we are in all the three cases, depending on the these are the three conditions which we have discussed before. So we have a removable discontinuity where you have got the limit exist and your f of a exists but they are not equal. Okay, so and then in the discontinuity of a first kind, we have limit, left hand limit and right hand limit both exist but they are not equal, and here neither the left hand limit exists nor the right hand limit exists. So therefore these are the three varieties of the discontinuities. Okay, now let us try to understand this particular concept, whether we have continuity or a discontinuity, depending on the say the with the help of example. Okay, so let me take one example to understand. So they say that they have defined f of x equal to x square minus 9 upon x minus 3 if x is not equal to 3, and it is equal to 5 if x is equal to 3. So we have to check whether the given function is continuous or it is not continuous at x equal to 3. So we have to check what happens to the function at x equal to 3. So now let's start with the given idea. So here we know that f of 3 is 5. This is equal to 5. This is how it is defined. Now let us see limit of f of x as x is tending to 3 is equal to, this is nothing but, as we know that given function is defined as x square minus 9 upon x minus 3 as x is tending to 3. Okay, so this is equal to limit, now this is like a square minus b square. Let me write it down here. Yeah, this is equal to limit as x is tending to 3. This we can write it as x plus 3 x minus 3 upon x minus 3. This x minus 3 we can cancel. As x is tending to 3, this will become 3 plus 3, which is equal to 6 here. Okay, so here if you observe, we have got thus we have got limit of f of x as x is tending to 3 is 6, and f at the point of 3 is defined as 5. So both are not equal here, right? So it is existed, limit exists and the function at the point is exist, but they are not equal, so which is like a removable discontinuity. Therefore clearly we can say f of x as x is tending to 3 is not equal to f of 3. Hence the given function is removable discontinuity. it has a removable discontinuity at a point, say x equal to 3, okay. Now let me take another example where we have, it has been defined as, the given function is, say example, we have f of x equal to x cube minus 8 upon x minus 2 at x equal to 2. Let's see how exactly this function behaves. Now this function is defined this way, at x equal to 2 is like this. So we have to check whether the given function is continuous or discontinuous. So this function at x equal to 2, if I put it at x equal to 2, this function becomes 0 by 0, which is not defined. So let me write here, f of x is not defined at x equal to 2, because if I put x equal to 2 here, it becomes 0 by 0, okay. So then this is not defined here, all right. Then since f of 2 is assumed to be 0 by 0, right. However, now what we take, limit of f of x as x is tending to 2. Let us find out the limit as x tends to 2. This is equal to limit of x cube minus 8 upon x minus 2 as x is tending to 2, okay. So here it is like a cube minus b cube form. We know a cube minus b cube form. So this will be a minus b into a square plus ab plus b square. So let me write that way. This implies limit as x is tending to 2. This one we can write it as x minus 2. Here b will be 2. So x minus 2 a square x square plus ab, that is 2x plus b square, that is 4, okay, divided by x minus 2. So this, now x minus 2 I can cancel. So as x is tending to 2, just put wherever x is there 2. This will be 2 square plus 2 into 2 plus 4. So 4 plus 4 plus 4, which is simply 12, okay. So therefore thus we concluded that thus the limit of f of x as x is tending to 2 is 12, which is exist. So the limit exists, okay. Therefore now what we understood is, the given function at f at the point of 2, we are not able to define it, right. So therefore we concluded that therefore it has a discontinuity. F has a removable discontinuity, okay. This has a removable discontinuity at x equal to 2. So now how you make it as a continuous function? Then by redefining that function as, say, f of x equal to, we define it as x cube minus 8 upon x minus 2 when if x is not equal to 2, because this cannot be defined if x is 2. Therefore if x is not equal to 2, it will take this function, and it is equal to 12. It is equal to 12 if x is equal to 2, okay. So this is how you can define this function in order to check whether the given function is discontinuous or continuous, okay. Now if you see here, this is like redefined. In order to remove that removable discontinuity, I am redefining this function this way, all right. So this is another example for your removable discontinuity, okay. And then I think we are good with the types of the discontinuity we have discussed, and then the few examples we have quoted here. Now let me also take another I think, yeah, let me give you one example for you all to check whether the given function is continuous or discontinuous, and you can just answer me in the comment whether you get the answer or you will not be getting the answers for that. So that will be like, for example, if a function f of x is given as, say, x square minus 16 upon x minus 4, if x equal to 4. Okay, if x equal to 4, and then we have say this is equal to, we have got 8 if x is equal to, here if it is x is not equal to 4, here if x is equal to 4. Oh yeah, so please check whether it is continuous or not continuous. And the same I just rechange. The given function is, this is one example. Check the continuity or discontinuity. Then same one I just give you this as f of x equal to, say, x square minus 16 upon x minus 4. Check whether the given function is continuous at x equal to 4. Okay, so check the difference and comment the answers in the comment box. Let me know what you get. Okay, then I think we'll stop at this point. Maybe in the next video we'll discuss about the uniform continuity. Okay, till then, take care guys.